Next, we will discuss about our runtime data areas. We will discuss about what is happening inside runtime data areas. We will discuss about method area, heap area, Java stacks area, our PC registers and native method stacks, and what is happening internally in all these runtime data areas we will discuss now. Explanation on runtime data areas. So what runtime data areas will do for inside Java JVM? What runtime data areas will do inside JVM? We will discuss now. This runtime data areas will provide memory. Runtime data areas will provide memory to store bytecode and objects and method parameters and local variables and the returned values and some intermediate results of computations. All this will be stored inside runtime data areas. And the Java virtual machine JVM will organize the memory it needs to execute a program into several runtime data areas. We will see how it stores all those objects, parameters, bytecode. We will see clearly in depth with example. First, we will discuss about runtime data area, then we will see example. So, whenever we run Java command for executing a class, the Java launcher, which will be there inside JVM, that starts the Java runtime environment has a process in our operating system. We have discussed in before lectures about process machine. It starts runtime environment has a process in our OS operating system by occupying some memory from RAM. All this we have discussed in our before lectures. So if you did not get any idea, you can watch it. Already videos are available. And further, the entire Java virtual machine setup is divided into various runtime data areas that are used during execution of a program. All these method area, heap area, Java stacks, PC registers and native method stacks comes under. All these are divided into various runtime data areas that are used to during execution of a program. So some of these data areas are created on Java virtual machine startup itself and are destroyed only when the Java virtual machine exits. We will see all those. And some other data areas are created per thread. Java stacks area will be working by threads. We will discuss in depth in our Java stacks area descriptions. Next, per thread, these data areas are created when a thread is created and destroyed when the thread exits. So we will see one by one all these runtime data areas, how it works internally. First, I will make a note about all this so you will get some clarity. Runtime data areas provide memory to store bytecode, comma, objects, comma, method parameters, comma, local variables, comma, return values and intermediate results of computations. The Java virtual machine organizes the memory it needs to execute a program into several runtime areas. So, and we have discussed one more point. I will make a note about that. Whenever we run Java command for executing a class, then the Java launcher starts Java runtime environment as a process in OS operating system by occupying some memory from RAM and further the entire Java virtual machine setup is divided into various runtime data areas that are used during execution of a program, and some of these data areas are created on Java virtual machine startup and are destroyed only when the Java virtual machine exists. Exits, not exists, exits. And other data areas are created per thread. Data areas are created when thread is created and destroyed when thread exits. This is about our runtime data areas. So, how many types of runtime areas we have in our runtime data areas we will see now. JVM totally contains 5 runtime areas. What are they? We have already seen method area, heap area, Java stacks area, program counter registers, PC registers area, and we have native method stacks area. We will discuss one by one which runtime area is what it is doing internally. We will discuss all those. First, I will make a note about this. First one, method area. Next, we have heap area. Next, we have Java stacks area. Next, we have program counter PC program counter is PC registers area. And next we have native methods stacks area. These are 5 runtime areas we have in our Java virtual machine. We will see one by one which area is doing what it is doing internally, which area what work it is doing internally. We will discuss all those points. First, we will discuss about method area and heap area. First, we will discuss about method area and heap area. So, what method area is doing, what heap area is doing, we will discuss now. First, we will discuss about method area. Inside method area, in method area, every class bytecode is loaded and stored in our method area. It means the given class static and non-static. Non-static is nothing but instance variables. We can call non-static or instance. Static and non-static variables, declaration statements, our blocks, methods, constructors, and the logic will be stored inside our method area. I will show you programmatically how it is working internally. We will see with example. Now I want to explain you the introduction of our method area and heap area. And further, for all static variables, memory is allocated in this runtime area. In method area, all static variables memory is allocated in method area, method runtime area. So what is happening inside heap area? Heap is the main memory of our JVM, because all our classes and whatever arrays we are using, all classes and arrays objects are created inside a heap area. Means the given class instance variables memory is allocated in our heap area. Our heap area consists of class instance variables memory, and our class objects and arrays objects are created inside heap area. And for storing this given class bytecode inside JVM, one separate instance is created from java.lang.class. For storing Java class bytecode inside JVM, one separate instance is created from this package and class. That class name is java.lang.class. And as many classes we are loading, you can load hundreds of classes inside JVM. As many classes are we are loading into JVM, those many instances are created for java.lang.class. We will see how it works. And this method area and heap area are shareable memory areas to all the threads. Method area and heap area are created on virtual machine startup itself. So we have discussed in our runtime data areas. So here we have discussed that some of these data areas are created on virtual machine startup itself and destroyed when our JVM exits. Means whenever you use command like Java, some example means JVM is created with some process. At that time, some startup memory will be created, and whenever you exit our command, like our Java virtual machine is exiting, then those memory will be destroyed. And we have seen some other data areas are created per thread. Threads we will discuss in Java stacks area. Now we will discuss about method area and heap area. So how it will store our class data, like our static variables and non-static variables and blocks, methods, constructors, how logic will be stored inside method area, and how class objects and array objects will be created in heap area, we will see now. So this is my method area and this is my heap area. So method area consists of classes and class data. These are my multiple classes inside method area. We have already discussed method area can have so many classes inside method area. So all these are classes with class data. This is also one of class with class data. This class data consists of static variables, non-static variables, constructors, methods, and logics. Whatever we have written, all this will be storing inside method area. Inside method area, we have so many classes. All those classes consist of so much data. Data is nothing but variables, methods, static variables, non-static variables. All those will be stored inside this method area. So this is my method area which is having classes with classes data inside that class. All these are my classes. Inside my classes we have so many classes inside method area, and inside these classes we have that class related data. Data is nothing but static variables, non-static variables, and methods, blocks, constructors. So all the logic will be there in our class data. Like that we have so many classes, so much data. This is my method area. Next we will see about heap area. What will be stored inside heap area? We have discussed. Our class object and arrays object will be stored inside JVM. Means objects will be stored inside JVM, inside heap area. All these are objects, our class objects. For example, I have a class with bike, and if you create that bike class object, that objects will be created inside heap area. You can create multiple objects for classes. So for example, I have bike class. For that bike class I have some hundreds of I want to create some hundreds of objects, and that all objects will be stored inside heap area. So all these are objects. So all these objects we have all these objects memory will be having inside heap area. This is my heap area. So this is about method area and heap area. I will write all the points which we have discussed till now, so you will not forget all those points. First point is in method area, every class bytecode is loaded and stored. It means the given class static and non-static, which is nothing but our instance variables and blocks, and class consists of methods. and also class consists of constructors and logic will be stored in method area. And next we have discussed further for all static variables memory is allocated in this runtime area. Next, heap is the main memory of JVM. Next, all classes and arrays objects are created in heap area. Means given class instance variables memory is allocated in heap area. And next point, for storing given class bytecode inside JVM, one separate instance is created from java.lang.class. This is a main class. It will create one separate instance for storing our class bytecode inside JVM. As many classes we are loading into JVM, those many instances are created for java.lang.class, like as shown in diagram. I have shown in diagram. In this diagram I have shown you that point I have written in fifth point. So next, sixth point, both method area and heap area are shareable memory areas to all threads. And next we have, and this method area and heap area are created on virtual machine startup. These are the points we have discussed about our method area and heap area. And we have to discuss some more points. If there is no sufficient memory in method area for loading another new class bytecode, or if there is no sufficient memory in heap area to create a new object of any class, then JVM will throw exception, like some out of memory exception it will throw. And the heap memory size can be increased at the time of setting up of runtime environment using non-standard option like java-xms size. You have to give class name for this command. The method area and heap area may be of a fixed size or may be expanded as required by the computation and may be contracted if a larger heap becomes unnecessary. So method area and heap area may be a fixed size, and also we can expand as required for computation, but may be contracted if a larger heap becomes unnecessarily. So we will make note about all these points. If there is no sufficient memory in method area for loading new class bytecode, or there is not sufficient memory in heap area for creating new object, then JVM will throw exception like java.lang. Some out of memory error. You will get this exception if memory is not available to load the class or to create I will write one more time. If there is no sufficient memory in method area for loading new class bytecode, or there is no sufficient memory in heap area for creating new object, then JVM will throw exception java.lang. Out of memory error. It will throw this error. So we have already seen in method area or in heap area, if there is no sufficient memory to create one more class, to load one more class in method area, it will throw java.lang. Out of memory error in method area. And when it comes to heap area, for example, I have created 100 bike objects from our class bike. By using class bike object, I am creating 100 bike objects, like bike B is equal to new bike, bike B1 is equal to new bike, bike B2 is equal to new bike. Like that I am creating 100 bike objects, but my heap area size is I can create only 100 objects. So I have created one more object. Then you will get exception, because memory is not sufficient in our heap area. Then it will throw exception like java.lang. Out of memory error. This is what we have discussed just now. The heap memory size can be increased. Size can be increased at the time of setting up of runtime environment. Runtime environment using non-standard option. I will show you the command. By using this command, you can increase the size of our heap memory. Java dash xms, then you have to give size. After that you have to give class name, whatever the class you are using, either example bike, any class, that class name you have to give here. Then here you have to give size of that, whatever you want to increase, you have to give the size. This is my Java command to increase the size of heap area. And we have discussed one more point, like some 10th point. The method area and heap area may be fixed, may be of a fixed size, or may be expanded as required by the computation, and may be contracted if a larger heap becomes unnecessary. These are the points about heap method area and heap area we have discussed. Next we have seen theory points about method area and heap area, and we have seen how it works, but we have to see programmatically. I will create a class and I will create some static variables, non-static variables, some memory. I want to create some methods. I want to create some objects, and I want to show you how method area and heap area and this stacks, Java stacks area, all these 5 runtime areas, how my class will be loaded inside this runtime area, I will show you.